Here we're going to look at question 3 from the BMAT 2019 paper. So in this question, we're given a diagram of a cyclist with the forces acting on this cyclist shown. We're told that there's this 600 Newton driving force forwards, and backwards we have a 300 Newton force due to friction against the road, and some air resistance force, which we're not told. We're told that our cyclist is accelerating at 4 meters per second squared, and that the cyclist and bike have a combined mass of 50 kilograms. So what the question asks us to do is to find the value of this air resistance force, this resistive force here. So if you'd like to have a go at doing this question yourself, then please pause the video now, otherwise we'll have a go at doing it together. Okay, so to first try and answer this question, the first thing which I'd probably recommend doing is thinking about any relevant equations that we can think of, which might help us here. So there's one which is really useful generally in all of physics, and it's one of the kind of fundamental equations of physics most people learn first, and that is Newton's second law, which is that F equals ma, where F is the overall force acting on something equal to its mass multiplied by the acceleration from this force. Now, I personally can't think of any other equations which are probably going to be too useful, so we could probably just stop there, and we can try and think about how we can apply this equation to our situation here. So, how would we do that? Well, we can probably try and consider the overall force acting on our cyclist. Now, we're told that this overall force, well, we know that this overall force on the cyclist, is going to cause our acceleration of 4 meters per second squared, just because of this equation F equals ma. So the overall force from this kind of 600 newtons and 300 newtons plus air resistance in the backwards direction is going to give us this overall acceleration of 4 meters per second forwards. Now, the fact that we're considering the overall force is really important here. If we were to go ahead and just consider the 600 newtons and not this resistive force acting backwards, and that wouldn't necessarily make sense because this force is acting against this force and it's going to offset it slightly. So what we can do is just go ahead and work out what the overall force is actually going to be. And the way that we can do this is we can consider our arrows, and we can take the 600 Newton force in the forward direction and then take away the force acting in the negative direction or in the backwards direction. So that's going to be 600 newtons take away the 300 newtons plus air resistance. Now, since we're trying to find out what air resistance is, I'm just going to give it a name here. We could call it FA, just so we can write it algebraically a bit more easily. And simplifying this expression here, by expanding the brackets, is just going to give us that the overall force on our cyclist is 300 newtons take away this force due to air resistance, Fa. Right, now with this, we can go ahead and try and consider Newton's second law. So we can just move down. I'm going to put another picture of our cyclist up on the screen there, and we can consider our equation F equals ma. So we know that the overall force, F0, is going to be equal to the mass of the cyclist and the bike together, multiplied by the acceleration of our cyclist and bike, our 4 meters per second. So we can go ahead and substitute in our expression for F0 and these numbers, and we get that 300 newtons take away our force due to air resistance is equal to 50 kilograms multiplied by 4 meters per second squared, which of course we can go ahead and work out what the right-hand side is to tell us that we have this equation here, which we can rearrange to find the force due to air resistance of 100 newtons. So this is going to be our final answer and corresponds to answer B given in the question.